This is volumes of cones. You'll see that cones have a lot in common with pyramids. They both have a singular base and all of their sides lead up to a single apex point. To find the volume of a cone, it's 1/3 the product of the area of the base and the height of the cone. We're going to use the same formula to find the volume of a cone that we use to find the volume of a pyramid. It's going to be 1/3 of whatever the area of the base is times the height. Just like pyramids, as cones get higher, they slant inward, and the layers that we're stacking up will have less and less cubic units in it. If this was a cylinder that went straight up, it would hold 3 times as much volume as the cone. So to find the volume of a cone, we multiply by 1/3 or divide by 3. Let's take a look at some example problems here. So in this first example, we're being asked to find the volume of the cone and round our answer to the nearest tenth. Okay, so the base is a circle. So to find the area of the base, I'm going to do the radius squared, which in this case, our diameter is 4, so our radius is 2. Our radius squared times pi times our height, which is 6. So the first thing I'm going to do is the exponent, and get that out of the way. So I'm going to have 1/3 times 4 times pi times 6. And I can do all of this in my calculator at once, or I can do all of it and divide by 3 here. So if I do that, I'm going to get to the nearest tenth, 25.1 meters cubed. So that's my volume there. Let's take a look at this one where we're trying to find the height. They also want us to round our final answer to the nearest tenth. So I'm given the volume. It's 956. To find the area of the base, I'm going to do my radius, which is 9 squared times pi, and I'm going to do times the height. So in this case, I can first do my exponent. I get 1/3 times 81 times pi times h. So I can do 1/3 times 81, which gets us 27 times pi times h. I can then multiply my 27 times pi, and I'm going to round it to the nearest tenth. It's about 84.8. So I have 84.8. H is 956. To solve, I'm going to divide each side by 84.8. And roughly for my height, I get 11.3 feet for the value of h. Let's take a look at this real life example. So you must answer a trivia question before the sand in the timer falls to the bottom. The sand falls at a rate of 50 cubic millimeters per second. How much time do you have to answer the question? Okay, so currently we have our sand in the top part of the timer here, and it's going to be falling down, and when it all falls through, our time is up to answer the trivia question. So first I need to figure out how much sand is in there. What's the volume of that section? So I'm going to do 1/3 times the area of the base. I have a radius of 10, so 10 squared times pi, and the height of the sand is 24 millimeters. So I'm going to solve my squared first. I get 1/3 times 100 times pi times 24. I can do 100 times pi times 24 divided by 3 in my calculator. And for this, I roughly get an answer of 2,513.3 millimeters cubed. So that's the volume of sand that is in that timer. But that's not telling me how long I have to answer the question. Remember, it's falling at a rate of 50 millimeters cubed each second. So I'm going to take this total, 2,513.3, and I'm going to divide it by 50 to figure out how many seconds that gives me to answer the question. And I get about 50.3 seconds. So a little bit less than a minute to answer the question.